The moon. For centuries, it has been the subject of wonder and imagination, a silent companion in our night sky that has shaped the beliefs and stories of every human civilization. But for all of our stories, of werewolves, lovers, and poets bewitched by its glow, the true mysteries of the moon lie not in legend, but in the hidden facts buried deep within its ancient surface. Over the past few years, a new chapter in lunar discovery has begun. On the bleak landscapes of the moon, far from the touch of human hands, Chinese-crafted robots have been busy, scanning craters, gathering soil, sending home secrets never before glimpsed by humankind. What China has found there might just challenge the story of our own origins and shape the future of life on Earth in ways we are only beginning to imagine. Let's reel back for a moment and frame this in a context that covers not just the science, but also the awe. Picture this: Chinese lunar landers and their faithful rover companions nosing through the hostile, airless void, hundreds of thousands of miles from Earth. The moon's silence is total, interrupted only by the whir of tiny electric motors and the sharp impact of robot treads in ancient dust, untouched for billions of years. Yet, this silence is deceptive, because in this silence, Chinese scientists are finding a new voice in the grand unfolding story of the cosmos. The findings they've pulled from the lunar surface are unique, not only in substance, but in meaning. They hint at a moon more mysterious and more active than we ever dared to think. A sibling planet with a history so entwined with Earth that to understand its story is to unlock our own. The quest for these secrets did not begin with China. When American astronauts made their historic leap to the moon in the late 1960s and early 1970s, they brought back not only hope and inspiration, but also a treasure trove of lunar rock and dust. Scientists expected these samples to finally answer the fundamental questions about how the moon formed. Instead, the rocks left researchers more perplexed than ever. Lunar rocks, it turned out, were nearly identical in key ways to rocks found right here on Earth. This was deeply unexpected. If the moon and Earth had formed in completely different places, as two random bodies separately captured by gravity, why would their rocks be so alike? That question led to the prevailing theory that long ago, in the deep infancy of the solar system, our young Earth was violently struck by another planet-sized object, a body nicknamed Theia. The resulting immense impact vaporized both worlds, spewing out debris that would eventually cool and coalesce to form the moon. In this giant impact hypothesis, the moon is Earth's twin, born from the very substance of our planet's mantle. But theories, however widely accepted, are not facts. They're stories awaiting confirmation, and the more new samples we gather, the more complete, and sometimes more confusing, that story becomes. NASA's Apollo missions scratched the surface, literally and figuratively, of lunar knowledge. Their landings were limited to particular regions of the moon that were accessible and safe at the time. That left much of the lunar story unwritten, and vast swathes unexplored for decades. Now, it is China leading the quest for more answers. In the last 5 years, Chinese space missions have transformed our understanding of the moon, launching a brand new era of robotic exploration. Their focus? Some of the most mysterious and unexplored terrains on the lunar surface, especially the enigmatic far side. Here's the thing about the far side: not, as pop culture would have it, some dark, frozen plain. It gets plenty of sunlight. Its strangeness is not in its absence of light, but in its difference from the face we see each night from Earth. The familiar lunar man-in-the-moon face is made of huge, dark volcanic plains, the so-called mare, marked by ancient solidified lava flows. But the far side is different. Light, rugged, battered by the scars of countless asteroid impacts, and almost entirely devoid of those dark volcanic seas. Why is one side so different from the other? That question alone is worth a scientific lifetime. And so, in January 2019, China's Chang'e 4 mission landed, making history as the first spacecraft ever to set down on the moon's hidden hemisphere. Its rover companion, Yutu-2, embarked on a slow trek across the Von Harman crater, an impact scar almost as wide as the island of Cuba, and itself nested within a titanic basin, the South Pole Aitken, an ancient, battered reach nearly as wide as the country of India and nearly as old as the moon itself. Here was the perfect place to find secrets buried since the solar system's beginning. Von Karman crater is more than just another pit in the moon's armor. It's a window into the deep past. When the cosmic impact that formed it slammed into the surface, it punched straight through the moon's crust and exposed rocks from the mantle, the thick, rocky layer sandwiched between the lunar core and crust. The rocks unearthed here are relics not just of lunar history, but of planetary birth. In finding for the first time samples from the moon's mantle, Yutu-2 gave humanity access to clues Apollo never saw. But not all surprises are so easily cataloged. In December 2021, Yutu-2 beamed back a peculiar image, a cube-shaped silhouette on the far horizon, standing like a sentinel above the bleak plains. Was it an alien monolith, a message from the cosmos, or maybe a glimpse of something never before seen in the solar system? For a few tantalizing weeks, scientists obsessed over the image, until, after a slow approach, it was revealed as a simple trick of light and low resolution. Just a rock, cast in a strange shape by shadows and pixelation. Still, the mysteries kept coming. The Chang'e 6 mission rekindled the search, bringing humanity the very first samples ever to be returned from the moon's far side in 2004. These pristine, untouched samples changed the story once more. First, physically. The samples brought back were nothing like those collected from the near side by the Apollo missions. The far side rocks, lighter in color and far more lumpy in texture, with dust that clung together in sticky clusters. In addition, scientists expected that the far side, insulated from Earth's warmth in the early days, would have cooled much faster, preserving the moon's oldest volcanic rocks. And indeed, buried in the sample was a fragment of ancient lava, 4.2 billion years old. The oldest lunar rock yet discovered, forged when the moon was still freshly torn from the Earth's embrace. Yet the same samples also told a brand new story. They contained volcanic rocks far younger than anything expected on that half of the moon, averaging just 2.8 billion years in age. That's surprisingly recent, geologically speaking, especially for a side of the moon supposedly dormant and dead. This finding flies in the face of the prevailing Big Splash model, which holds that the smaller moon would have cooled and quieted long before the much larger Earth. In reality, it seems the lunar depths stayed hot and active for far longer than we believed. Even on the very side we expected most to be frozen and silent, the near side, for all its familiarity, is just as full of surprises. The American Apollo missions only scratched the equatorial plains, safe spots for landing, but dull for geology. Considering the moon's size, those landings sampled an area little larger than a sprawling city park. To truly know the moon, you need to go farther. And in late 2020, China did just that, sending Chang'e-Y to a bold target, the Rumker Dome, an ancient volcano in the northwest, far from the long-visited Apollo zones. Lunar volcanoes are not what you might picture. There are no explosive mountains spitting fire and smoke. Instead, these are gentle, broad domes, lava rising through the lunar crust in slow, steady floods that over millions of years create vast, flat layers. Digging at the Rumker Dome, Chang'e-Y exhumed the moon's youngest known rock, just over 2 billion years old, almost 500 million years fresher than most Apollo finds. This, too, forces us to rethink the moon's reputation as a cold, dead world. It turns out magma simmered beneath its skin until relatively recently in cosmic terms. But perhaps the most compelling discoveries are in the details. From those samples, Chinese scientists identified a brand new mineral, one never before seen on the moon or on Earth. They named it Changesite-Y, after the mission that found it. A colorless, transparent crystal, its secrets are barely larger than the width of a human hair. But it is remarkable for what's within it, the rare isotope helium-3. For decades, science fiction writers and energy visionaries have fixated on this elusive element. Helium-3, thrown off in a steady breeze by the sun, accumulates on the lunar surface in a concentration found nowhere else in the inner solar system. On Earth, our planet's magnetic shield protects us, keeping us safe, but also sweeping away most of this treasure. Were we ever able to develop practical nuclear fusion reactors, a frontier of science racing forward even now, helium-3 might be a fuel source beyond our wildest dreams. Enough clean, efficient energy to power the world 1,000 times over, without radioactive waste or the fears that haunt nuclear fission. It's not here yet, but the potential is real, and the moon could be the key. Yet energy is only the beginning. The Chang'e missions have also shed new light, literally, on the search for water on the moon. Previous missions found residue, signs of hydrogen and oxygen, the building blocks of water, but never actual H2O. Now, for the first time, Chinese scientists have isolated microscopic droplets of water trapped within newly identified hydrated salts in lunar volcanic soil. Proof positive that water exists, not just in frozen, shadowy craters, but on sunlit plains, and potentially everywhere. Water, more precious than platinum, is the true currency of space exploration. It means we could set up future lunar bases, not just at the poles, but almost anywhere. No longer do we have to confine our ambitions to a few shadowy craters. Permanent outposts, scientific laboratories, even refueling stations for voyages deeper into the solar system, all become far more feasible. This is why China's lunar robots are more than just remote-controlled explorers. They are laying the foundations for the next great leap, a human return to the moon, and perhaps the beginning of genuine lunar civilization. The Chinese approach has been methodical, focused, and scientific. Where Apollo was bold and breathtaking, a triumph of human daring, racing to the moon and back, China's program is painstaking and persistent, more like slowly assembling the world's most complex puzzle than like chasing a single great prize. In doing so, they have not only rewritten what we know about the moon, but redefined the future for us all. The moon isn't just a relic to admire, nor a hostile wasteland to avoid. It's a new frontier, one that holds mysteries about ourselves, our planet, and potentially our destiny among the stars. But let's take a step back. What do these rocks and minerals, these discoveries of ancient volcanoes and water droplets, really mean for us? Back on the blue and green homeworld? Why should ordinary people care about mysteries 250,000 miles away? For scientists, the moon is a living timeline, a geologic diary of the early solar system. The oldest rocks brought back by Chang'e missions are over 4 billion years old. Their chemistry, structure, and isotopic makeup preserve the clues to the violence and chaos of Earth's own birth, long lost to plate tectonics, weather, and life. Okay? By comparing rocks from different parts of the moon, both the near and the far side, researchers are able to test theories about planetary formation, not just for the Earth and moon, but for every rocky planet in the solar system. The questions run deep. Did planets form quietly, or in a series of cosmic collisions and chaos? Are twin worlds, like Earth and the moon, rare accidents, or nearly inevitable wherever you find worlds around stars? And the more the samples diverge, the more variations there are from place to place, the more we learn. Differences in composition, in volcanic activity, in the age of the rocks, all these map a picture of the moon's evolution, and, by proxy, give us a mirror to Earth's ancient history. But for visionaries, policymakers, and even entrepreneurs, the stakes are even greater. Water, minerals, helium-3, these are resources with the power to change human society. In an age where earthly resources are finite and climate threats loom, the promise of clean fusion fuel or extraterrestrial water could be transformational. The moon, once a symbol of barren alienation, is slowly revealing itself as a future source of hope and abundance. The discoveries made by China's lunar explorers have also supercharged ambitions worldwide. The United States, Europe, Japan, India, and private companies are once again racing to the moon, not for glory alone, but for science, commerce, and the seeds of something bigger. International partnerships and rivalries are being forged and tested on the plains of lunar rock. Still, lunar exploration is not solely about the practical benefits. There is something more profound, a calling that has echoed through generations, reminding us that exploration is a fundamental part of being human. When we go to the moon and bring part of it back, we are not just chasing rocks. We are reaching for knowledge, for wonder, for a sense of home in the cosmos. As China leads the way into this new lunar era, scientific surprises continue, and each one raises new questions. If the moon's far side is so different, why? Could it have been struck by different types of asteroids or affected by ancient hidden forces in the early days of the solar system? Why did lunar volcanoes remain active for so long against all models? How much water is really there, and can it be accessed? Is helium-3 truly as abundant and as usable as we dream? How did new minerals like Changesite-Y form, and where else might they be found? On the moon, on Mars, on distant worlds we have yet to reach. Every mission, every scoop of alien dirt and fragment of crust brings us a step closer to these answers. Each time a robotic arm descends to the dust and drills core samples, humanity takes one more stride across the void. We stand on the edge of a new age, one where the moon is not just a trophy to be reached, but a partner to study, a resource to share, and, one day, a home to visit, and perhaps even to call our own. Imagine, not so far in the future, astronauts standing beside robotic explorers, harvesting water from the soil of an ancient crater, building habitats in the lee of long-dead volcanoes, powering their world with energy from a sunlit sea of helium-3. The moon, once only a ghost in the night, will have become a bridge to understanding ourselves, to surviving on a changing Earth, and to traveling wider across the solar system. The story of what China has found on the moon is not over, not by a long shot. Each new mission brings fresh mysteries and new discoveries, and every answer sparks additional questions. But in this golden age of exploration, the icy silence of the lunar surface is slowly giving way to the quiet hum of science, of telescopes unfolding, robots moving, the future being made. From the far side to the near, from ancient lava plains to volcanic domes, from colorless crystals to hidden pockets of water, the moon is revealing its secrets that shape not only our understanding of one celestial companion, but of all worlds everywhere, and of the people bold enough to chase those answers. As we look up tonight toward that familiar, steady glow, we can be certain that the story of the moon is changing. It is no longer a distant, unknowable orb, but an open book, a partner in our journey through the stars. And the question, what did China find on the moon? These days is fast becoming the question, what will humanity find next? This is only the beginning of a great adventure. The moon is no longer silent. It is speaking its history, one discovery at a time. And for the first time in human history, we are truly listening. If this expanded explanation inspired you or gave you a deeper understanding of the realities of space, please like, subscribe to Space Future Now, and share your thoughts in the comments. Let's explore the universe together, safely, boldly, and always with wonder.